Welcome back again, and today we'll be talking about, still inside our on-site guide, the one that is updated to BS 7671 of 2018 and to the amendment 2 of 2022. And today will be interesting. We'll be talking about cable capacities of conduit and trunking in Appendix E. So what are the factors that is to be considered while doing this? Some of the factors are the reasonable care of drawing, acceptable use of space available, tolerance in cable sizes, and tolerance in conduit and trunking. And these are the factors that must be considered when assessing the capacity of conduit or trunking. Now, there is a disclaimer here, and that is what is already in bold. Only the ease of drawing in is taken into account. The electrical effect of grouping a knot. As the number of circuits increases, the installed current carrying capacity of the cable decreases. Cable sizes have to be increased with consequent increase in the cost of cable and conduit. What does this mean? This means that this calculation, or what I'll be showing you today, is only for the sake of easy drawing in. If you want to know if the cables you have will easily go through the size of conduit you have, then this information will be useful for you. But there's another calculation about grouping factor. This does not affect that. So we just want that to be clear. So in this example for today, I'll be using the single core thermoplastic, which is PVC insulated cable in straight runs of conduit exceeding 3 meters in length or in runs of any length incorporating bends or set. Why did I choose this one? Because the PVC insulated cables are the ones that are mostly used because they are cost efficient and you just find them everywhere. That is what most electricians use. So I'll be using this one as the example. And most time when you're installing your conduit, we normally pass 3 meters in length, because even most conduits are just 3 meters in length. So generally it will be of 3 meters or even more than 3 meters. This is table E3, and it talks about cable factors for use in conduit in long straight runs over 3 meter or runs of any length incorporating bends. To make this simple and clear, I'll be using an example here. So the example I'll be using is using an example of 2.5 mm cable. So if you see here, you see conductor cross-sectional area, that is 2.5 mm. And the cable we're talking about could be either solid or stranded. It will be single core, but either solid or stranded. And each cable have what they call a cable factor. And in this case, the cable factor for 2.5 mm is 30. So what do we do with this piece of information? So let's go with this example so that you can understand easily. So say for your conduit, you want to install or draw in 6 single core cables. I don't know if you understand me. Single core cable, that is 6 when counted, 6 of them. That could be, say you want to draw in like 2 circuits into your conduit. So how do you know if that cable will be able to fit in the kind of conduit you want to install? Or another question could be, what kind of conduit should you install? Using this example, you go with the cable factor, which is 30 in this case. Cable factor differs depending on the type of cable size that you're using. But in this case, our example is 2.5 mm. You can use any kind of cable. You should use the factor that corresponds to the cable size. So in this case, it is 30. So you do 30 multiplied by the number of the cables that you'll be installing your conduit. In this case, in our example, we're using 6 single core cables. 6 single core cables. So what you do is go 30 by 6. What do we get? We get 180. So this is the first piece of information you want to get. You want to get your cable factor multiplied by the amount of cable you'll be putting in your conduit. In this our example, it is 6. So we did 30 multiplied by 6. What's the next thing we need to do? Now we already get the answer. The result of that is 180. What is the next piece of information? Then the next thing is to go to this table. cable E4, and this is conduit factors for runs incorporating bends and long straight runs. So what we've talked about, the first thing is the cable factor. The next thing we want to do is the conduit factor, and this can be found on this table E4. So how do you work with this table? Well, this table has some information. You have the length of run of the conduit you want to put, the conduit size. We have 16 up to at least 32, and we have if it's a straight bend, 1 bend, 2 bend, or even 4 bends. So in this case, what do we do with this information? Well, let's use another example so that it will be more easier for you to understand. In this our example, we'll be using, we'll say our length of run of our conduit is 8 meter. 8 meter maximum, 8 meter. That's what we're using here in our example. And we'll be say we want to install 20 mm conduit. Now we need to know, will 20 mm conduit, will it work for us? Well, follow me along. So first thing, you know, this piece of information that you have, you want to use 20 mm conduit, and the length of the run of the conduit that you install is 8 meters. So what do? We go to this number. This number, when you trace it from top to the to this side and you trace it back, it gives you 213. So the conduit factor here is 213. Those are the two main information. The conduit factor here is 213. So what do you do with these two information? Now you've seen that if you install 6 single core cables and it only have 1 bend, you see in this table, the part that we select is the part of 1 bend. If you only have 1 bend and it's 8 meters maximum, that is the length of run, the conduit factor is 213. So what you need to do generally when you have those two pieces of information, cable factor and conduit factor, then you see which is greater. If the conduit factor is greater than the cable factor, then you are good to go. But if the cable factor is greater than the conduit factor, then you have a problem here. In this our case, our cable factor is 180, conduit factor is 213. Cable factor is less than 213, so 20 millimeter conduit is acceptable if you'll be installing 20 millimeter conduit with 6 single core cable in it of maximum 8 meters length with 1 bend. So let's now say you want to do something different. You want to install the same kind of cable, but now you want to use 2 bends. Let us check that out. This is it right here. We have 20 mm conduit, still the same 8 meter, but now we are going with 2 bends. What do we have? We have 159, and this is the cable factor for here. Conduit factor rather is 159. Can we still install this same conduit size with 2 bends? No. Why do you say so? Don't forget the cable factor is 180, and we said earlier that whatever you want to do, the conduit factor must be greater than the cable factor. In this case, the conduit factor is 159 and the cable factor is 180, making 20 millimeter conduit non-acceptable for this kind of installation. And this is just a principle, and this principle can be applied onto different sizes of conduit. Here we have 25 mm, 32 mm, and also depending on the length you have, up to 10 meters, you can install your conduit, and you can use this formula anyway, anytime. So if you want to calculate for other cables sizes, you can also always go to the first chart. You can go back and you check this snip. You can even snapshot that page there, and you compare your cable factor and your conduit factor together, and that will be able to help you to perform a good installation. And why do you need this? Generally, if you do not go do your due diligence and know the right cable, the right conduit to install, it's possible that you run your conduit and later find out that when you're pulling your cable in, you cannot go in easily, and that will not be good for you. And sometimes you may already have some amount of cable in your conduit already. So what do? You want to know, can you pull more? This can help you to know if you can pull more or not. So this is a very helpful tips that can work for you on site, and can always come back to watch this video so that you can understand it better, or anytime you want to do this simple calculation. Thank you for watching. Until another time.